Welcome to the new streamlined developer experience for creating custom automated market makers with Balancer v3. Get ready to speedrun writing a liquidity pool contract that uses the constant product formula popularized by Uniswap v2. But before we start writing the AMM logic, the first step is to set up our contract to inherit from the Balancer pool token, which simply requires that we add a constructor that defines a vault address, a pool token name, and a pool symbol. And we'll also need to import the iVault interface. Now we are ready to begin composing the logic for our AMM by inheriting from the iBase pool interface, which puts the developer in control of computing the invariant, computing the balance, and defining the logic for swaps. So let's begin with the onSwap function. Since we are planning a constant product AMM using the invariant x times y equals k, we can derive the swap logic using the pool's current token balances and the amount of the token coming in. With that information, we can calculate the amount of the token out using the formula pool balance token out times amount token in divided by pool balance token in plus amount token in. Now it's worth noting that if you disable unbalanced add and remove liquidity operations, which you can do during pool registration, you don't actually have to implement compute invariant and compute balance. But since we do want to allow liquidity providers to add and remove unbalanced token amounts, we'll move on to compute invariant. And to help us compute our invariant, we will use the fixed point library from Balancer's v3 Solidity utils and math from OpenZeppelin. Additionally, let's go ahead and use fixed point library for all UINT 256s. And the formula we will use is the square root of x times y equals k in order to maintain a stable liquidity balance and minimize price slippage during large trades. So let's start by scaling the invariant value to 18 decimal places. Then multiply the invariant by the balances of the tokens in the pool. And finally, we'll take the square root and multiply by 9 decimal places to maintain the 18 decimal place scale. And then we'll move on to implementing compute balance, which calculates the new balance of a token after an operation given the invariant growth ratio and all other balances. To find the new invariant, we simply take the old invariant and multiply it by the invariant ratio. Then find the pool balance of the other token that we are not computing the balance for. And finally, square the new invariant and divide by the pool balance of the other token. And that concludes the core logic for the constant product automated market maker. So the only thing left to do now is to set a minimum and maximum swap fee percentage. And now you might be wondering, what does the process look like for deploying, registering, and seeding a pool with initial liquidity? Well, we've got you covered with Scaffold Balancer v3, the ultimate prototyping playground for creating custom pool types and pool hooks, set up to run on a local fork with a burner wallet that instantly signs transactions to help you visualize the changing state of your custom pool as you perform swaps, joins, and exits. Explore our curated list of pool hooks contracts and debug your code in style. So now just one question remains. What will you build on Balancer v3?